Hello, thank you very much, Yasmina. And hello, everybody. This is kind of fun. This is my first webcast on since we actually had the ability to do voice real time, so this will be sort of a new experience for me. We're going to start off today, and we're going to be talking about how to connect your iPhone to an Arduino, which is actually kind of a cool thing to do. When you think back a couple of years ago, that really wasn't possible because the Arduino is really set up to talk to devices using a serial port. And Apple has been a little reluctant to let all of us actually use serial ports on iOS devices. So it was kind of difficult back then, but there's been two avenues opened up since then that allow us to actually talk to Arduinos with iOS devices. One of them is Bluetooth LE, which we'll kind of refer to obliquely later on and is covered in the book. And the other one is using Wi-Fi, and that's what we're going to talk about today. So let me see if I can get the first slide up, and we'll go over what we're really going to do. So what we're going to do is to create a project that actually demonstrates both input and output. And the reason for that is basically so that you're not, creating just a simple little project that lights an LED or something. I mean, that's a great way to get started, but we wanted to get a little more complex than that and actually show both input and output since we're trying to demonstrate two-way communications. On the other hand, it is still a simple project. The emphasis here is on how to actually make the connection, how to actually get the iPhone and the Arduino talking to each other. Once you get them talking, what you do with that is really up to you. We'll cover some ideas later on in the talk at the very end and look at some places where you can go to find some resources to look for ideas on what you can do with that Arduino now that it's connected. So what our actual project is going to do is we're going to start off and have a button that you can press, and that's the input. So the button is going to be hooked into the Arduino. Once that signal is sent to the Arduino, it's going to talk over a device called a WiFly, which is a Wi-Fi to serial bridge. That will then in turn communicate with the iPhone over the Wi-Fi connection that we're going to set up, and the iPhone program running in techBASIC will actually get a signal saying that the button has been pressed. Once it gets that signal, it's going to do something pretty simple. It's just going to count the number of times the button has been pressed. And each time the counter is incremented, it's going to send a number back to the Arduino. The Arduino is going to display that number on a binary display that we're setting up with 3 LEDs. So that's basically what we're going to do. Let's take a look at that and see how that's really going to work. So in a moment here we go, you're going to see a flash video that just shows the project in operation. So pretty straightforward there. You're seeing the little binary counter go from 1 to 8. So what we're going to actually look at is we're going to take a real detailed look at the parts list so you can go out and start grabbing your own stuff. And I will give links later on to the places where you can go to get all of these parts, although a lot of them you probably have just laying around if you do many electronic projects like this. We're going to give complete wiring directions, so we're going to show you exactly how to hook up all the hardware. I'm going to go through that kind of slow for some of you who are familiar with electronic projects because there's folks in the audience who are software types and may not be too familiar with how to hook up the hardware. So if you are a hardware type, it's going to be a little basic, but for those of you who are not, we'll try to keep you from blowing up your Arduino. Then we're going to go through the Arduino software. Again, we're going to step through that relatively slowly and carefully for people who aren't familiar with how to actually program on the Arduino. And perhaps we'll have some questions, and you folks can pop up and let me know, what it is that you want to know that I'm not covering there. We're also going to cover the iOS software. So the iOS software will be running on your iPhone or your iPad or your iPod, and that's the part that's actually going to take the input from the Arduino and send the number back. We're going to look at how to actually set up the Wi-Fi connection. It's pretty straightforward, but it may be something you haven't done before. And this is actually what's going to tell the iPhone to talk to that Wi-Fi device. And once we've finished with all of this and taken a look at how this project works, we're going to stop and take a look at a couple of other ways to connect to the Arduino and to some of the built-in sensors on the iPhone and iPad, as well as one particular wired sensor, which is kind of fun. And we'll wrap up today. We'll take a look at, now that you know how to connect the Arduino, what can you do with it. Just as a footnote, if you have any questions, we're going to be stopping occasionally, to take a look at those. This is one point, so pop them up there if you've got them. And as we finish each of these sections, I'll stop and answer any questions that you might have had. So let's dive in and take a look at the parts list. So this is a view of the entire project, which I set up on a breadboard. You can run this with an iPhone, an iPad, or an iPod. The nice thing about connecting with Wi-Fi is that all iOS devices have Wi-Fi. So all you need is one that has at least iOS 5. And the only reason you need that is so that you can run techBASIC. If you wanted to do it in Objective-C, you could rewire the whole project and do it on literally an iPhone 1. techBASIC is the programming language we're going to be using. That may seem a little odd to some of you who have an Objective-C background, but there's a really good reason for that. techBASIC was designed for this kind of stuff. It was set up to allow you to do technical programming on the iOS device. So if you're a Windows programmer, for example, and you don't have access to a Macintosh with Xcode, you can do all of the programming right there on your iPad or your iPhone. It also gives you the ability to connect with Bluetooth and a few other ways. It's got a pretty nice built-in graphics package and so forth, so you can do quite a lot with the language. The next thing we've got down there is the breadboard itself. So you probably got one laying around. There's nothing particularly special about this one. The power supply is kind of a fun one. It's a particular power supply from DF Robots that actually has both 5 and 3.3 volts. And the reason that's nice is that the Arduino, of course, uses 5 volts. But the Wi-Fi, like an awful lot of small footprint devices these days, is actually looking for a 3.3 volt, not a 5 volt input. And supplying 5 volts could be bad for the device. It might actually fry it. So you're going to want to make sure that you supply 3.3 volts to that one. This power supply can supply both. Now, that said, if you're familiar with the Arduino, you also know that that has a 3.3 output. So if you really wanted to, you could use a single 5 volt power supply, and you could tap the 3.3 volts off of the Arduino for the Wi-Fi device. The Wi-Fi is the piece that's actually going to talk to the Arduino and to the iPhone. There's a couple of ways you can use it. What we're going to be doing with it is using it as a very simple bridge between the Wi-Fi connection on the iPhone and the serial connection on the Arduino. And you'll see some other things later on about how to use that bridge to connect to other serial devices. That particular device is set up on 2mm pin spacings. So all of you folks over in Europe are going, well, yeah, it's about time we use millimeters over here. And those of you in the U.S. are going, but all of my breadboards are 1/10 of an inch. So you've got to have some way to go from one to the other. And that's actually the XB breakout board. It's a little printed circuit board that you can buy specifically to convert from the 2mm spacing of the XB and the Wi-Fi, as it turns out, and the 10mm spacing of a standard breadboard. The Wi-Fi itself is actually set up with the same pinouts as an XB. So if you've already got parts for the XB, you don't need to get anything new. I'm using 3 LEDs for the output, for the digital outputs, and you can see those over towards the right of the project. They're sort of brighter, the ones that I'm using straight up, so the one on the bottom looks brighter, but the one on the top is lit up as well in that particular photo. These are resistorized LEDs. If you've ever used LEDs in a circuit, you know that they always tell you to put a resistor in there, and you're looking at my circuit going, oh my gosh, he forgot the resistors, he's going to burn out the LEDs. But these have the resistor built in. They're pretty handy for little projects like this because you don't have to wire that resistor in separately. You can obviously substitute regular LEDs and, say, a 330 ohm resistor if that's what you have in your parts box. The Arduino Uno is down there at the bottom. That's a fairly common form of the Arduino. It's the first one I latched onto anyway. I've got a couple laying around for projects. You could probably use a number of the other kinds of Arduino if you like, but that one's pretty easy to find and get a hold of. You need to reach into your parts box and grab a 10K resistor. We're going to use that for the switch. And, of course, you've got a switch of some sort that you need. If you really want to go old school, you could just hook up a couple of bare wires and touch the bare wires together. It would work just fine. So that's our parts list. Now, before you go running out trying to frantically do internet searches and so forth, I'm going to give you a link towards the end of the talk to a website that has all of the information from the talk. That website also has links on the parts list to take you directly to some various online stores that sell these parts. Okay. Let's take a look at how to wire the circuit. And like I said, I'm going to go through this a little bit slowly and talk about some of the details. So the first thing we're going to look at is how you actually hook the Arduino up to the WiFly. Now these are both talking to each other through serial ports. So what that means is you've got one wire running from the Arduino to the WiFly, and that one is sending information from the Arduino to the WiFly one bit at a time. And they'll sit there and communicate the information, putting bytes together and sending it over the line. Now, when the Wi-Fi wants to talk back to the Arduino, it's got a second wire, and that wire connects back to the Arduino itself. Those are the yellow and orange wires that you see, and also the little purple wires that are connecting the yellow and orange wires over to the WiFi device. Now, on the WiFi, you're using pins 2 and 3. For those of you who aren't too familiar with how those pins are numbered, the WiFi device has 20 pins, just like pretty much anything with that sort of a footprint. They're numbered from the top left starting at 1, so the 2 pins that we're using are numbered 2 and 3 right below that. Pin 2 is the transmit pin, so that's the pin that the WiFi is going to use to actually send signals out to the Arduino, and we're going to connect that onto the Arduino on pin 3. That's actually the pin on the Arduino that's labeled RX. That's its receive pin. So that's how the Wi-Fi talks to the Arduino. Going the other way is the yellow wire. That's connected to pin 2 on the Wi-Fi, or I'm sorry, on the, yes, pin 2 on the Wi-Fi. Oops, I'm sorry, myself twisted around, didn't I? The transmit pin is 1 on the Arduino, and going back to the receive pin is 3 on the Wi-Fi. Okay. Next thing we'll wire up is the switch itself. Now the switch is actually going to be hooked into a digital I/O port on the Arduino. So you can do a little bit more with it than what we're doing, but we're treating it as a simple on-off switch. We're going to raise it to 5 volts to tell the pin that the switch is pressed. We're going to drop it to ground to tell that the switch is not being pressed. So pressing the switch is pretty easy. We're going to run a wire from pin 5 on the Arduino over to our breadboard and into the switch. The other end of the switch is going to be wired through that orange jumper back over to the red bar on that right-hand row of pins, and that one is eventually going to get wired up to 5 volts. So when we press the switch, we'll be putting 5 volts into that pin. The other side, though, is what if the switch isn't being pressed? Well, we need to actually drop it to ground. If we don't, then the Arduino gets confused. It's not quite sure what the voltage is, and it can report all kinds of things, and your switch will flop back and forth as far as the software is concerned. So what we do is we put that 10K resistor in series so that if you're not pressing the switch, the current will drop down to the ground through that yellow wire and going through the 10K resistor. Well, so we're sort of short-circuiting it. And the reason that works out is that when you press the switch, there's 0 resistance, and so everything gets treated as it's going to the 5 volts. Now, there's some bounce on that switch. We'll talk about how to get rid of that later. Bounce occurs when you press the switch, and just as the contacts are starting to make a connection, you can get an on-off, on-off, on-off kind of a situation because the connection's sort of there, but not quite. We're actually going to deal with that in software, so we'll cover that in a moment. Okay, now we've got the switch wired up. We need to wire up our outputs, and our outputs are those 3 resistorized LEDs. We're going to connect those to pins 2, 3, and 4 on the Arduino in that order. So pin 2 will be bit 1, pin 3 will be bit 2, and pin 4 will be bit 4, so that we've got the 1, 2, and 4 over there on the right-hand side. Now, when you're wiring up those resistorized LEDs, if you look at an LED, you're going to find out that one of the wires is almost always longer than the other wire on the bottom of the LED, and that's intentional. The long wire goes to positive, So it's going to go back towards the Arduino side, and the short wire goes to negative, so you can see that those yellow jumpers are pulling it over to the ground side on that power strip. You might also see, if you feel it carefully on this particular LED, it's hard to do it any other way, that one of the sides of the LED is flat. That flat side always goes to the negative side of the circuit. All right, let's take a look at the power. So in this case, I'm using that DF robot power supply, which I mentioned before that I kind of like. Let's take a look at how I actually wired it up. The power supply itself is designed to plug into adjacent power strips on a breadboard like this one. On the left-hand side, you've got 5 volts, and the next one over is 3.3 volts. So we're going to pull the power for the Wi-Fi off of that second power strip, and we're going to pull the power for the Arduino off of the left-hand power strip. But if you remember, I was also wiring stuff up to the right-hand power strip, so we need to get some power over there too. And on the right-hand side, you can see how I did that. I connected that blue and green jumper wire to connect that top power strip to the right-hand power strip. You can't see this, but underneath of the power supply on the left-hand side is a similar blue and green wire connecting the left-hand power strip to the top as well. So that's how the power is getting over there. And pull up that next slide. So now we need to actually connect the Wi-Fi up to the power. And the Wi-Fi actually wants to use pin 1 for plus 5 volts and pin 10 for ground. It may not look like it's really connecting to the bottom left of the Wi-Fi device there. You have to sort of peek at it from the side to see where those pins are. But that is pin 1 and pin 10, the top and bottom pins on the left-hand side of the Wi-Fi. That black spot up above, by the way, is the antenna for the Wi-Fi. There's several different models. We're using the one with the built-in wire whip antenna. It's about, it's about as long as the Wi-Fi is. It's just sticking straight up in the photo. Now you might also notice that I've got another pin wired up to plus 5 volts. That's pin 8. And what that does for us is it tells the Wi-Fi to start up in ad hoc mode. There's a couple of ways you can actually use the Wi-Fi. The way I'm using it here is I'm telling it to set up its own little network, and that's what that wire does. So when we actually get to the point where we're connecting to the network, we'll take a look for local hotspots on our iPhone, and we're going to find out that there's a brand new one, and that's the Wi-Fi. We can also hook it up as part of an existing network. I'll let you play with that on your own. The last step is to hook up the Arduino itself. And in this case, we're just going to run 2 wires, one from the 5-volt connection on the Arduino back over to the left-hand power strip, and the other one on the ground connection to the Arduino, and that goes back over to the left-hand power strip as well on the negative side. And that completes the circuit. So let's see. It looks like someone is asking a question on what the advantage is of a Wi-Fi over a BT, Smurf, or Mate, or B. And basically, you can use several different devices to make that bridge. The Wi-Fi is one that I've used and works pretty well. It's simple, it's cheap, it seems to be pretty rugged. And but you know, if you've got experience with one of the other devices, go for it. Now, Bluetooth is a different kind of an aspect. Bluetooth lets you hook up using devices without tying up your Wi-Fi connection the way we're going to do with the Wi-Fi. So that is kind of interesting. And we'll look at that in a moment. But the disadvantage of Bluetooth is it's only available on certain devices. Now, I say that because you're sitting there saying, well, I've been using Bluetooth headphones with my iPhone since the iPhone 1, and you're right. But there's 2 kinds of Bluetooth. There's the Bluetooth that's the classic Bluetooth called Bluetooth 2.0, which is the one that you're using with headphones and keyboards and that sort of stuff. There's another kind of Bluetooth called Bluetooth Low Energy or Bluetooth 4.0 or Bluetooth Smart. They never quite figured out what name to use. And that particular kind of Bluetooth is not controlled by Apple's MFI program. The result of all that is that people writing their own apps who don't join the MFI program are allowed to use Bluetooth LE, but they're not allowed to use standard Bluetooth. You can do that with techBASIC if you've got an iPhone 4, iPhone 4 or above, I believe, maybe 4S. I'll have to double check that for you. And the iPad 3 and above, and you can do that with the most recent iPod. But before that, you can't use Bluetooth. So that's one of the reasons why the Wi-Fi device is nice, is this works on any iPhone with iOS 5 or better. And somebody asked if techBASIC will work on iPhone 1s. And the only restriction on techBASIC is that it has to have iOS 5. I don't really think the iPhone 1 will support iOS 5, but if it does, then yes, techBASIC will work on an iPhone 1. And another question we had was, WiFly is from SparkFun, and is that any different from the one I'm using? No, actually I bought mine from SparkFun. You can get it from a number of places, but that happens to be where I got mine as well. Okay, let's move on then. We're going to take a look at the software for the Arduino next. And this is actually not too bad. If you've done C programming before, it's pretty straightforward and it's not a whole lot of software. We're actually going to be tracking pin 5. Now let's think about how this is working. As far as the Arduino is concerned, you can look anytime you want and see whether the button is pushed or not. But that doesn't really tell us if somebody just pushed the button. So what we're going to do is we're going to set up a variable called pin 5, and we're going to initialize it to low, which means the button is not being pushed. And what we're going to use this variable for is anytime we look at the pin, we're going to look at it and see, well, is it high or low right now? And then we're going to compare it to the pin 5 value and see what the last value was. If they're different, something changed on the switch and we need to do something about it. If they're the same, nothing has changed since the last time we looked, and we'll ignore the fact that we've read the switch at all. The next step is the setup method, and that's actually called by the Arduino when the program starts. It's sort of like main, if you will, in a standard C program. So it's going to get called once at the very beginning, and we can do all of our setup stuff in that particular one. Now, the setup is starting off and setting up a serial I/O port, telling it to run at 9600 baud, which is the default for the WiFly. Then it's going through the various pins we're using, and it's going to tell the Arduino whether we want to use those as an output pin or an input pin. So if you recall, I said 2, 3, and 4 were going to be the outputs for the LEDs. So we set those 3 pins up to the output, and then pin 5 is going to be the input for the switch. So we set that one up as an input. The last subroutine is actually a little bit longer. It's the loop subroutine. And this is one, if you're familiar with the Arduino, it's called periodically to do periodic tasks. So while the Arduino is not doing anything else, it's going to jump in here and run the loop subroutine. We're going to do whatever we want to do. Then we're going to exit. Then it's going to come back and call the loop subroutine again unless it's doing something different. So what are we going to do? Well, the first thing we're going to do is we're going to check and see if the iPhone told us anything. That's what serial.available does. It says there's something, is there or is there not something available on the serial line? And if there is, it returns true, and we'll do the rest of the stuff. If not, we'll drop through and ignore it because nobody's telling us to do anything right now. Now, if there is something available, the next thing we need to do is to read it. So serial.read reads a byte from the serial port. We're only expecting 1 byte, so we're only going to read 1. If there happens to be another one paired up, we'll drop through, the loop subroutine will run again, and we'll catch it on the next pass through the subroutine. So we read that byte, and then we're going to check the byte and make sure that it's a byte that we expect, because every once in a while you might get a spurious signal coming through on the serial line. You'll see that actually more from the iOS side when the WiFi device starts sending out a bunch of signals when it starts up. But we do some defensive coding here and just make sure that the value that we're getting is what we expect, which is a single digit from 0 to 7. So now we get down to the part where we're actually going to do something with it. We know we got something, we read it, we've got a digit, it's from 0 to 7, and we need to display that on the LEDs. The way we're going to do that is to look at the 3 bits that are in that particular number. It's convenient with the ASCII character set. We don't have to worry about the fact that there's actually some extra bits out there to indicate that this is a number. The numbers are actually set up so that bits 1, 2, and 4 really are bits 1, 2, and 4 for the number. So we're just going to peel those off. At the top, you see we're peeling off bit 1 with an and if it's set, we're going to turn the LED connected to pin 2 on by setting it to high. If that bit is 0, we're going to turn it off by setting it to low. And then we do the same thing for bit 2 and bit 4. The last part of the loop subroutine is to go the other way. We're going to basically take a look at pin 5. We do that with a digital read command. So digital read on pin 5 tells us whether or not pin 5 is set. So if it's not set, or I'm sorry, it reads the pin, it says us something is available, then we're going to set pin 5 to whatever it is. Excuse me, back up a moment. We're going to read the pin and see if it's not the same as what we already have set. If it's changed, we're going to set pin 5, the variable, to pin 5, the state of the pin on the actual Arduino. Then we're going to check and see if it's high. Because if it's low, we don't really want to do anything. If somebody let up on the switch, we're not going to count it, so we ignore that. So if it's high, then we're going to write an asterisk character through the serial port, and that's going to go to the iPhone. So that's actually the end of the Arduino software. We've got the 2 sections, one to read the value from the iPhone and display it on the LEDs, and the other one, which I stumbled over a little bit, apologize for that, to check the pin and write an asterisk anytime somebody pushes that switch. So let's see, we've got a couple of questions that have piled up. Let's see now. Could you explain the static pin 5 command again? Static pin 5. So let's back up a couple of slides. I think you're asking about the variable itself, right, Terry? So what the variable is used for, we just went through on the Arduino at the end of the loop subroutine. If that wasn't clear, can you pop that question up again? But I think we probably answered it by going through that last section of the loop subroutine. All right, so moving on, we're going to go to the iOS software side. So over on the iOS, we're going to write a program in techBASIC. So you're looking at something that's written in the basic programming language, the same one that you use on pretty much any other basic programming setup, like maybe scripting for Word or doing Visual Basic or whatever. It's interesting, though, BASIC was originally designed way back in the 60s, about the same time C was being designed, in fact, for scientific programming. And it had built-in arrays and all kinds of features that really weren't seen in computer languages for another 10, 15 years, and even today are not standard in most computer languages. So BASIC was originally designed as a scientific technical programming language, but Visual Basic and some of the other implementations dropped a lot of those scientific commands. techBASIC is putting them back. It's also putting in some commands for things like communication, and that's what that first line is all about. com.openTCP/IP tells techBASIC to open an I/O channel using TCP/IP. It's using I/O channel 1. So if you're familiar with BASIC, all of our I/O commands are going to be able to take a channel number, like the print command on the next line, which is saying I'm going to print something to channel 1. What this is doing is opening one of those channels, and from here on out we can use standard basic I/O commands to do either binary read and write, or we can, as we have here, just use the print command and print a value straight to the Arduino. The next parameter in that particular command is giving the IP address for the device that we want to talk to. And we'll cover that a little bit more when we get to the section where we're actually connecting to the device. But you need to remember this first line of the program because your device may actually not connect at 169.254. And if it doesn't, you're going to have to come back to the program and change that first line to use whatever IP address that your device is displaying. And finally, the WiFly wants to talk using port 2000. So we tell it the port number there is the last parameter of that TCP/IP command. Then to get things rolling, we're going to print a 0. So that's going to send a 0 over to the Arduino and tell it to turn off all of the stuff on the Arduino. So all the LEDs go black. Then we're going to set the count to 0 so that we agree with what we just sent to the Arduino, and we're going to use that count variable to count the number of times the button has been pushed from the Arduino side. The next couple of lines are setting up a timer. And this is where we're going to handle that switch bounce that I mentioned. So when you press a switch, you can get that momentary contact, and just as the switch is being pressed, it can flip on and off several times very, very quickly. So we're going to actually time the time between one asterisk coming in from the Arduino and the next asterisk coming in from the Arduino, and if they're too close together, we're going to ignore them. So the timer variable is being set up with the current time so that we don't react with those button presses too quickly. And here's the rest of the program on the iOS side. So really pretty darn short. We could make it shorter, but I tried to make it simple instead of short. So I was a little breezy in the way that I wrote the program. The null event program is just like the loop subroutine back over on the Arduino side. The null event subroutine is called periodically when techBASIC isn't doing anything else to let your program do some other stuff. One of the things that it passes is the time when it's making that call, and that's what we're going to use compared to the previous time that we stored to make sure that we're not reacting to switch bounce when we're reacting to switch presses. So with that in mind, let's take a look at what the subroutine does. First, we're going to look and see if we have an end-of-file condition on the I/O channel 1. So if we don't have an end-of-file, that means there's something available for us. If we do have end-of-file, that means that the Arduino hasn't said anything to us yet, or actually the WiFly hasn't said anything to us yet. The reason that's important is because the WiFly, as soon as it hooks up, is going to send over a hello stream that basically has some, hi, I'm here kind of information. And so we'll pretty much ignore that. If we have reached the end of file, so there's nothing available, we'll just drop out of the subroutine and we'll get called again later on. If we're not at the end of file, then we're going to actually read 1 byte. And this is a basic command for actually doing binary input. So it's going to get 1 byte from stream 1 and put it in the variable b tilde. The tilde says that variable is a byte variable instead of an integer. Then we're going to check and see if it's one we want. If that particular value is a character asterisk, then we're going to process it. If it's not, then we're getting something spurious like that hello stuff that came in from the Wi-Fi when it woke up, and we'll ignore it. So now we're going to drop through and say, okay, we got an asterisk. Has it been at least 1/2 of a second since the last asterisk that we saw? If it has been 1/2 of a second, then we'll drop in and do the other stuff. If it hasn't been at least 1/2 of a second, we're going to assume that switch bounce, and we're going to ignore it. The next line records the time that we actually saw this particular asterisk so that we can start the counter again and wait another 1/2 second before we see the next one. So all of that was housekeeping to make sure we really had to do something. Now we get down to the point where we actually do something with it. So we have an asterisk. We're going to count it. So we're going to set the count variable to be the previous count plus 1. Then we're going to check and see if it's above 7. If it's above 7, then we're going to set it back to 0, roll it back to 0 so we don't keep going with 8, 9, 10, and all the other numbers that, if you recall, the Arduino software is going to ignore. Once we have a number that we want to send, we're going to send it off to the Arduino with the next command, print stream 1, the count variable. And because we're using the print command, it's going to automatically convert that number to a character and send the character 0 through 7 over to the Arduino. And the little semicolon at the end tells it not to send an end-of-line character, which the Arduino would ignore, but it avoids putting too much traffic on the serial port. And finally, just for debugging purposes, we also print it to the techBASIC console so that we can watch and see what techBASIC is doing with all of this at the same time and make sure that the number techBASIC thinks it has is really what's showing up over there on the Arduino side on those LEDs. And it looks like we don't have any new questions, so we'll press ahead. So at this point, we've set up the software on the Arduino. We've set up the software on the iOS side. We've got all the wiring hooked up. So now we should actually be able to run the circuit. So you're going to push the power on the power supply. Up there at the top on mine, it's that blue button that you saw on the images, and it's going to come on. You'll get a bunch of blinking LEDs on the WiFly, and then you want to connect to it. So you're going to crank up your iPhone or your iPad. You're going to go to the Settings app. The Settings app is the one that you use to connect to Wi-Fi devices wherever you are. When you bring it up now, you're actually going to see a new one. It's going to be called WiFly-GSX- and then you're going to see 2 digits. They probably will not be D3. That just happened to be the one that showed up on the Wi-Fi when I took these screenshots. That can actually change even from one time you run the iFly to the next. If you tap on the blue disclosure button on that one, you're going to, well, first off, you have to tap on Wi-Fi-GSX to connect to it, of course. And then you're going to tap on the blue disclosure button like you see in the second image, that blue arrow over there to the right. That's going to take you into some details about this particular network. The reason you're doing that is twofold. The first is you want to know the IP address, and the second is you want to make sure it's there. The IP address won't actually show up until the Wi-Fi has completed its connection to the iOS device, and it may take a couple of seconds before that happens, so be a little patient, give it some time. As soon as that IP address shows up, then the 2 devices are ready to talk to each other. And you'll also see that the IP address is 169.254.46.56. Now, the 169.254 is what was in the techBASIC software. So if that happens to be the same on your Wi-Fi device, and the chances of that are kind of slim, then you're good to go. If it's different on your Wi-Fi device, then you're going to need to go back to the basic program and set it to be those 2 first numbers. Ignore the 46.56 though. Those should be 1.1 because the Wi-Fi actually sets itself up to be the device 1.1 on that network. So once that's all happened, you've actually got a connection to the Wi-Fi. Now you're at the point where we were with the Flash movie, and you can push the button and see the LEDs roll around and count up. So it looks like there haven't been any more questions reported, so let's move over and talk about something else that people asked about a little bit earlier, and that's Bluetooth LE and other ways that you can connect. So there's lots of ways you can connect to the outside world with your iPhone. The one we just looked at with Wi-Fi connection is one. Going through a serial port opens up a huge number of possibilities because pretty much anything can talk to you with serial port. So that lets you connect through Wi-Fi. What about Bluetooth, though? We mentioned that earlier in response to a question. So you can use Bluetooth LE on the devices that support it, which is the iPad 3, the iPod with the long screen, and the iPhone starting with iOS 4. Any earlier device doesn't support Bluetooth LE, so you won't be able to use it unless you join the MFI program and build your own hardware and build in a chip from Apple into each particular piece of your hardware that you build. Then you can use standard Bluetooth. Hijack is another one that we'll look at, which allows you to do a wired connection. And then finally, we'll look at the internal sensors because maybe you don't need an external device. The iPhone itself has an awful lot of sensors built in. So here's some of the things that you can actually do with a Bluetooth connection. So Bluetooth LE lets you connect to, on the top picture, an Arduino. So in this particular case, which is one of the samples straight out of the book, we've hooked up a Red Bear Bluetooth LE shield, and we've set that up so that we're connected to the car through an iPhone. And the program on the iPhone is set up so that as you tilt the iPhone forwards and backwards, the car will go forwards and reverse. And if you tilt it left and right, the car will turn left and right. The original car was a cheap Radio Shack special that had forward, reverse, left, and right and no proportional control. But we actually look at how in the book you can hook it up so that you have proportional control. So basically, as you start to tilt it a little bit, it's only going to power the motors for a while, and as you tilt it more, it powers them more and more. There's nothing special about using Bluetooth on this. With the techniques we've just talked about in the talk, you could replace that BLE shield that you see on top there with the Wi-Fi device and do exactly the same project using Wi-Fi. Down at the bottom, we have one of my personal favorites. That's an iPhone going into that model rocket, and sitting above it is a TI sensor tag. So what I was doing there is I was actually using the more sensitive accelerometers and barometers, which iPhone doesn't have a barometer, to actually track the altitude of that model rocket. So you can go to the book and to our website and see some of the data from it. But we tracked the model rocket. My wife lent me her iPhone for that. She was very kind or very silly, I'm not sure which. And we did get the iPhone back. no cracks, no damage to it at all. And flew it a couple of times. We also flew the Bluetooth sensor, the sensor tag, without the iPhone in a smaller, lighter rocket. But the problem with that is that Bluetooth does have a limit on its range. So Bluetooth is normally limited to about 100 meters. Testing the specific device with an iPhone, what I found out is that it was good to about 20 to 40 meters, depending on how you held the iPhone. And if you're trying that on your own, if you point the screen at it or the back of the iPhone at it, you get a longer range than if you point it in, straight onto the device. I would guess that all that metal around the edge of the iPhone is interfering with it a bit. So how else can you connect? Let's take a look at a couple more ways. At the top here on the left, you've got a moisture meter. That's actually done using hijack. That's that thing sitting up at the top of the device that's plugged into the iPhone, to the speaker port. Now, the hijack is an A to D converter, so it's an 8-bit A to D converter. And we're connecting it up to essentially a resistor, a variable resistor that works by looking at how much moisture content is in the soil to make that moisture meter. Excuse me. Down at the bottom right, we've got the WiFly showing up again. In the book, I actually don't show very much about how to hook it up to an Arduino. Nothing as extensive as what we did in this talk. But we do talk a lot about how to hook it up to servos, which are a lot of fun. So the servo lets you do a rotational motion, and you can convert that to a push-pull motion. On the top project, we've got it using rotation for an eyeball. And I'm sort of planning some fun stuff for Halloween with that eyeball. And on the bottom project, we've got the motion being converted to a push-pull motion so that I can walk up to my candy dispenser with my iPhone and flip the switch and get candy out of my candy dispenser. But I mentioned that there's one other way to get data from an iPhone, and that's to use internal sensors. So don't forget that you have an accelerometer, a magnetometer, and a gyroscope and GPS all built into your iOS devices. Well, most of them. Some of them don't have a few of the devices, but all the recent ones have all 4 of those particular sensors. And you can also combine GPS and the accelerometer and the magnetometer to get some other information, like which direction your iPhone is pointed or what direction you're actually traveling. In the book, we take a look at one project that's actually a metal detector. So what you're seeing there is the signal that I got from the metal detector when I passed it over top of one of the aluminum keyboards on a Macintosh. Now, we talked about how to connect an Arduino to an iPhone. And that was, the whole focus of the talk. But I realized some people may not know what you're going to do with the Arduino once you get it connected. So there's a few other books that you might want to take a look at which tell you things you can do with an Arduino once you've actually got it all hooked up. So the Arduino cookbook is a huge book. It's like 600 pages or so. That tells you specifically how to hook up all kinds of stuff and do all sorts of projects with the Arduino. It's not iOS specific, but using that book and anything that's connected to a serial port, you'll be able to connect it to iOS now and command everything from iOS. The second book actually looks at some specific sensors, and so it goes into a little bit more detail on those sensors than the basic Arduino cookbook does. It's looking at things like an ultrasonic rangefinder, for example, and it also looks at how to hook up to an XB network, which you should also be able to use with a little work here with techBASIC. And finally, if you want to play around with something that's a little bit more serious, you can look at environmental monitoring with your Arduino and hook it up to your iPhone to actually sample and record the data, maybe plot it, take a look at running plots and so forth with the graphics commands that are built right into techBASIC. This one actually shows you how to do water quality, electric fields, and my favorite, it actually lets you build a little Geiger counter and hook it up to your Arduino, which I think is kind of cool. So that's what we've got in terms of the talk for today, and we're running just about right on time. We've got time for some more questions if there are any. It looks like 2 have popped up, so I'll start with those. So the first question, Steve is asking if you could set up the Arduino and Bluetooth to multicast to 2 headphones and devices. And yeah, actually you can set up using Bluetooth LE you can set up to any device to communicate with multiple other devices, and you can set up an iPhone or an iPad to receive as well. There's an example of that in the book where we actually use 2 iPhones and an iPad, and we set up a palm game. So the iPad is the display screen and is controlling everything. The 2 iPhones are actually used as palm paddles, and you tilt them back and forth, and that controls the paddles on the iPad. So what's happening under the covers is the iPad is using Bluetooth LE to communicate with 2 iPhones at once. And Steve also asked, could you debounce the switch on the Arduino software side instead? And you could absolutely do that. But the Arduino software was already 3 pages, and techBASIC was only 1.5, so I figured I'd do it in the techBASIC side, and that way I would actually have something to do in techBASIC. But sure, you can do it on the Arduino side. You can also do it with electronics if you wanted to go through and put in a couple more chips. So there's lots of ways to skin that particular cat. And Michael is asking if techBASIC was running the code, and he's asking if techBASIC can generate a standalone app. In the case that I was showing you here, yes, techBASIC was running the code in a program that you could have typed in right on the iPhone or the iPad without using any other computers. If you want to actually run it as a standalone app, you can do that too. But that does involve a Macintosh. And the reason it involves a Macintosh is because that's the only way Apple will let you create anything that's going to go onto an iPhone or an iPad using the App Store or ad hoc distribution. So what you do at that point is you get techBASIC App Builder, which is a separate little device or app that runs on the Macintosh. That's designed to take all those programs that you wrote on techBASIC on your iPad or iPhone. It moves them over, runs inside of Xcode as a library to create a standalone app that you can submit to the App Store. And if you'd like to see an example of that, you can take a look at an app called SensorTag that's on the App Store. That's one that's from ByteWorks, and that shows you an app that was compiled using techBASIC App Builder and is distributed as a free app to access the TI SensorTag. That particular app is also a sample code in techBASIC, so you can look at techBASIC and look at the sample code to see exactly what's in that app. Whoa, now the questions are really piling up. Okay, so let's see. Roy is asking to discuss the alternatives to techBASIC. Well, there's one. There's Objective-C. So what you would do with Objective-C is you would program on a Macintosh using Xcode and Objective-C. It does require that you join Apple's developer program for $99 a year, but Xcode itself is free. At that point, you can go ahead and rewrite these programs using Objective-C. They're going to be a bit longer because Objective-C is designed for different purposes than techBASIC. It's not designed to do connections like this simply and easily. But the Wi-Fi connection it's only 2 or 3 classes and maybe, what was it, I would say 8 or 10 methods to set up and do the Wi-Fi connection, and then you could go ahead and do it in Objective-C. If you wanted to do the connections like we were looking at with Bluetooth, they're a little bit more extensive in both techBASIC and in Objective-C, but you've got examples in both places. We have a question from Ali. If you're using the Wi-Fi shield, do you require any special library to use it? And let's see, the WiFly, no, you don't. What you saw was the whole shebang. The software for the Arduino was the only software that was on that particular Arduino when we ran the project, and the software on the techBASIC side was the only thing on that side. Now with Bluetooth, the Bluetooth shield, you do actually need a little bit of extra software. That's covered both on the site for the Red Bear BLE Shield and in the book, if you wanted to get the book and take a look at it there. Nicholas is asking if there are any Android alternatives to techBASIC, and the honest answer there is I think the only one is Java, but I'm not absolutely sure. You might be able to look around. Things are a little more open on the Android, a little bit more friendly to people implementing languages, so there may be a couple of others that I'm not aware of that actually do implement TCP/IP communications directly, but Java I think would probably be the first choice over there. And let's see, Ali, I'm not sure, I'm sorry if I mispronounced it, is asking, does the Wi-Fi require any prior configuration before use? And not the way we used it. So the way I set it up was as an ad hoc network. So the only configuration it needed was running that wire from pin 8 to plus 5 volts. I certainly could have done it other ways, and you might have had to do a little more configuration that way, but I picked a fairly simple way to do it. So that wire was all the configuration you had to have. And while we were answering those, Danny came through, does BLE run on Mac or on Windows? And it runs on the Macintosh. The issue is whether the Macintosh has BLE. So we have to look at two things here. One of them is the software package. So do you have a software package that can actually recognize a Bluetooth low energy device and talk to it? The other one is the hardware side. So pretty much any computer has Bluetooth. So you might think you're okay, but that's not actually the case. Bluetooth low energy and Bluetooth share a name, and that's their biggest similarity. Bluetooth is a completely different radio signal from Bluetooth low energy, and they require different hardware. Now, if you go out there, you may find some devices that have both built in. That's certainly possible, but normally you're going to find either Bluetooth LE or Bluetooth. Now, the recent Macintoshes, for example, all have Bluetooth low energy built in, and you have the same Bluetooth low energy commands under Xcode and Objective-C on the Macintosh that you would have using Objective-C to program the iPhone. So you would be able to write the same program roughly with a different user interface on the two computers and talk to the Wi-Fi or to a BLE device that way. Windows, the more recent computers from a few manufacturers are starting to come out with Bluetooth low energy, and you should be able to communicate with those. I saw on the Windows Pad devices that they were planning on coming out with Bluetooth low energy support on the software side sometime this summer. I never noticed if they actually got that done, so you'd have to check on that on your own. On the Android side, things are starting to settle down a little bit. I'll just answer that question even though Danny didn't ask it, and I know there's a couple of Android folks in the audience. On the Android side, up until just a couple of months ago, it was sort of wild and woolly with Bluetooth low energy. There were a few phones out there and pads out there that actually did have Bluetooth low energy hardware, but the standard Android software did not have Bluetooth low energy software. So the situation you faced was you had to use some sort of a proprietary roll your own Bluetooth low energy code on each individual device. Recently, we got Bluetooth low energy software standard on the Android. I haven't actually had a chance to use it yet, but that should let you actually program the Android device and talk to any physical device that has a Bluetooth low energy radio built in. And Sirkan, I'm sorry if I mispronounced your name. Can you elaborate on the wireless communication hardware options for Android? Oh, well, I guess I was answering that while we talked, wasn't I? And use this if your concern is price. Use this if your concern is features, etc. Okay, so wireless communication on the Arduino. I'm sorry, I read that as Android, didn't I? There's really basically the two that we've talked about. So you've got Bluetooth low energy, and you've got the Wi-Fi devices that give you a Wi-Fi bridge to the Arduino. The third option, if you're programming on your own, and it is realistic if you're programming on your own, is a direct serial connection, but that's not wireless, so we won't go over it too much here. So of those two wireless options, the cost, as I recall, the WiFly was not terribly expensive, $30, $40, and the bridge that I used was a little bit more expensive. I think the advantage of using the BLE bridge, though, is that it lets you free up the Wi-Fi port, and it lets you talk to as many devices as you like. So, for example, if you set up an Arduino as a weather station, and you were sensing the wind speed, the temperature, humidity, all that kind of neat stuff from your Arduino, you could use a Bluetooth connection to actually talk to all of the iOS or Android or whatever devices were in range, and they could all look at that information at the same time. You could do that with the WiFly as well, I suppose, with the network connection, but it's a little dicier there. I think the real difference, though, is in the hardware availability, because some of the older devices can't use Bluetooth Low Energy. You really can go to the Wi-Fi and use those on all the older devices, and that's really the main advantage to me of the Wi-Fi connection. For my own projects, frankly, I prefer Bluetooth Low Energy when I can use it. I just think it's a little bit tighter of a communication method. Now, the software side, there's a difference also. The software communication with a serial port through the Wi-Fi is pretty darned easy. Bluetooth is a little more complicated. There's plenty of examples around in techBASIC and quite a few floating around now in Objective-C, but it is a little more complicated to talk to that Bluetooth LE device. So if you're great with hardware and you're not so great with software, you might want to consider going with the Wi-Fi instead of the Bluetooth Shield. And Danny is asking, what about making a web server on the Arduino and using HTTP and a web page? And you could absolutely do that. There's all kinds of ways that you can connect using Objective-C or using techBASIC. You can use HTTP, you can set up an FTP server or whatever, and it's on the techBASIC side, it's pretty much the same as what you saw before. You're going to use an open command to open up a port to HTTP, or to the FTP side using an open, HTTP or open FTP, and supplying the various ports and so forth. Once you've done that, you just read and write. So yeah, it will work just fine. And I think that's all of the questions that we have queued up so far. Did I miss any over in the group chat? Because I was looking at the question window.
No additional questions have come in, Mike, so we'll just make one final announcement. Folks, we are running out of time here. The webcast is about to conclude, and we'd like to let you know, please, if you do have a question for Mike and what he's been talking to you about and showing you, open that group chat widget. If you didn't open it yet, type it in, send it in, and we can still take one or two more. Back to you, Mike.
Okay. And let me see, I'm just going to refresh. I'm playing with the other tools right now, so we've got... let's see, right now people may have started leaving, but we've got a little over 100 people in the chat, so thank all of you for coming. And certainly get back to me with any questions after the chat as well. You can always get to me on the ByteWorks support line, so support@byteworks.us, and you can visit us on the web page. Since the questions have started to taper off a little bit, I'm going to push one URL out to you, and that is the blog that I mentioned. If I can figure out how to do this, let's see. Here we go. So everything we've talked about here today is also covered in a blog, which should be coming at you right about now. That blog is available on the ByteWorks website. One of the reasons you might want to go to the blog is that if you scroll down and take a look, the parts list has links. So if you don't have some of these components, I've got at least one source listed there where you can go find all of the pieces to build your own.
Right.
And I have to admit, I didn't put the software up on the website because it was just so darn short. So you'll just have to copy and paste it out of the blog itself.
Perfect, Mike. And with that, folks, we are going to say a very big thank you to Mike for presenting a really outstanding and fascinating webcast for us all today. Thank you, Mike.
Thank you. Thanks for having me.
Folks that attended, we thank you for attending our event today, and we had many of you joining from all over the world, and we know some of those parts is very late, so we do appreciate you staying up and participating in the event today. We hope you enjoyed it. We would like to let you know that we did push out a couple things to you all in the group chat. So if you haven't opened it, please do. Some good things in there to provide information as well as save you some money. Mike's new book, Building iPhone and iPad Electronic Projects you can get that book today. It's available now. Right now, if you go to the site, it might have an early release banner on it. Within 30 minutes, that is going to be gone, and you can get the book today. We have a code that will save you 50% on the ebook version as a thank you for attending the webcast. So if you like what you heard and saw today, that book has so many more cool things in there for you all. How about controlling a candy machine with an iOS device? Creating an arcade game with an iPad controller and 2 iPhone paddles? Or hack a radio control truck with Arduino and Bluetooth LE? Just some of the fun things that are in that book. So we encourage you all to take advantage of that discount and check it out. Also, we pushed out to you all links to Mike's website, so you can follow up regarding techBASIC, get information there, as well as the blog. So that blog post has lots of good information there. It accompanies the webcast today. It's on your screen right now. Again, we thank you, Mike. Thank you, everyone. This will conclude today's webcast. Goodbye, everybody.